Cloud seeding has been in the news lately, so let's go over cloud seeding. Exactly what is it? Well, just to make rain in general, you have to have a cloud. That cloud is made up of billions and billions of little tiny droplets of water. As those droplets of water come together, they get bigger and bigger, fall out of the cloud as rain. Or if you have a cloud with supercooled droplets of water, then those supercooled droplets will come together and form ice crystals that fall out as snow. Well, cloud seeding gives that whole process kind of an oomph, a little nudge, a push, if you will. The way it works is you'll have a plane, or sometimes the cloud seeding can be done on the ground, but typically it's done with a plane that flies over or into a cloud, and it will disperse a chemical, typically silver iodide. Silver iodide inside of a cloud attracts water droplets, so it speeds up and helps initiate even faster that process of those raindrops coming together, and gives it a better chance of producing more precipitation than it otherwise would. Inside of a supercooled cloud, where those water droplets are right on the edge of freezing but they're not frozen yet, then that silver iodide will act as an agent which will help crystallize and start that crystallization process, which again will help create snow, but if not create snow, amplify the snow being created and maybe drop a little more snow on the ground than otherwise you would have. So what are some quick facts regarding cloud seeding? Typically, it will generate maybe 10% to 15% more rainfall with the right conditions. Now, that's on average. You can go to some sources and find as low as 5%. You can go with some sources and find as high as 30%. Most have an average of 10 to 15%. So if you take that 10% average and say you get 1 inch of rain, add 10% to that, you get 1.1 inches of rain. With the example in Texas, the forecast was 5 to 7 inches of rain. So 5 to 7 inches of rain plus 10% is 5.5 to 7.7 inches of rain. Nothing near even close to the 15 inches that actually fell and caused all of the devastating flooding. Clouds can be seeded by plane or ground generators that will disperse the agent into the air, and it will work its way up into the clouds over a period of about 15 to 20 minutes. What chemical agents are usually used? Silver iodide primarily, but potassium iodide, dry ice, liquid propane, those are the principal ones. There are others, but 90% of the time, those are the ones that are used. Now, we're talking about putting chemicals in clouds. Is that harmful? Again, completely depends on who you're talking to, what source you're looking at. Some people say that there is no risk at all with any of these agents. They're found in nature and it's all good to go. Others say they are chemicals and they are harmful to mankind. I would encourage you to do your own research and know about the sources that you're getting your information from.
And finally tonight, in these confusing times, you might have seen posts or videos connecting cloud seeding to what is happening in Texas. And then earlier tonight, the CEO of a weather modification company confirmed that planes in Texas did release silver iodide into the atmosphere 2 days before the floods. But he also explained why he says scientifically it does not mean that the two events are connected. Watch this.
We're talking about like sub-centimeter amounts of precipitation, be it in snow or rain from every event, which in aggregate can mean hundreds of acre feet, which is very consequential for farmers and ecosystems, but cannot come close to causing flooding unto itself.
And NBC News climate reporter Chase Kane joins us now. Chase, any conspiracy always starts with like a thread of truth here. Can you explain the science? Like, what is cloud seeding, first off, and how is it being used in Texas?
Yeah, so cloud seeding is really this idea for farmers of like, hey, there's some moisture up there in the clouds. Is there a way that we can get it out of the clouds down here to the surface to help farmers? Because water vapor that's in the air needs something to grab onto, which is often like smaller than the tip of a pen. So you're thinking like pollens, particles of pollen or dust or even air pollution. So you see this graphic here. Basically what they do is they fly planes up there to give the water vapor something to grab onto. So it's a combination of silver iodide and salt, actually. And so the water vapor forms around that. Eventually it gets heavy enough and then falls to the surface of rain. So when that happens, we're talking really small amounts of rain. In fact, scientists have been debating for decades whether or not this is actually very effective to do. So even when it does work, Gotti, we're not talking about a lot of rain, certainly not the amount of rain that they saw in Texas last week.
And the timing of it, 2 days before, I mean, you know, again, anybody online that seems to be an expert these days would say, well, no, this is what, you know, started the flood or possibly like supercharged the soil so it was hydrophobic. Like, take us through the timeline here.
Yeah, that's a really important point, Gotti, because this cloud seeding, it works within like 15 minutes, half an hour, maybe an hour, and then that's it. So that was done 2 days before. So the CEO saying this, other scientific research establishes that cloud seeding isn't going to trigger something like this, certainly not 2 days after they were doing it. They were only up in the air cloud seeding for about 20 minutes because, again, it's targeted to a pretty small area of land, which was not even over where the worst of this flooding was, Gotti. So we're talking 30 minutes to an hour, certainly not 2 days in advance.
And I mean, cloud seeding is human-caused climate change on a very micro level. But when we're talking about climate change on the macro level, does it look like this flood has any links to climate change?
I mean, well, yeah, the kind of apples and oranges here, right? Because cloud seeding is like weather modification, like very hyper-local in the moment. Climate change is over a long period of time. And what humans have been doing by burning coal, oil, and gas is that we're making the atmosphere hotter, we're making the oceans hotter. But the hotter we make our atmosphere, it holds more moisture. I mean, that's just basic physics that we've known about for about 200 years. So the climate deniers say, oh, no, there's no way this is possible. But it's actually just basic physics dating back to the 1820s. The hotter we make the atmosphere, the more moisture it holds, and that comes down unevenly. So this group of scientists out of Europe did what's called a rapid attribution report, and they found that this storm was up to 7% wetter. It dumped up to 7% more rain because of climate change, because of those atmospheric physics, again, Gotti, that we've known about for 2 centuries. This is not some new conspiracy theory. This is just basic science.
Yeah, 7% becomes massive when you're looking at going from like 1 foot to 34 feet in a matter of 24 hours. Chase Kane, really appreciate your expertise in all of this. Thank you so much.
We thank you for watching, and remember, stay updated on breaking news and top stories on the NBC News app or watch live on our YouTube channel.
We're here in Santa Barbara County, home to one of the longest running cloud seeding operations in the country. We've got some ground-based cloud seeding equipment right here, and we're going to get to hear all about how it works and see it in action. Let's check it out. Cloud seeding is the most common type of weather modification, and it has many different techniques and applications. Today, it's mostly used to increase rain and snowfall, reduce the size of hail, and reduce fog at airports.
Traditionally, cloud seeding has been done from the air. So airplanes have had racks on them where these same flares are positioned on the airplane, and the airplane flies into the storm. So in order to reduce the cost to the client and reduce our carbon footprint, we've been able to station these on the ground. Now we can do this in places where weather permits.
Behind a barbed wire fence designed to keep away curious cattle, the cloud seeding gear awaits the right kind of weather.
So these are referred to as AHOGs. That stands for Automated High Output Ground Seeding Systems. We've got 3 primary components of our equipment here. The first is the control module that you see behind me. Then we have our actual cloud seeding flares. The camera is for security. It also helps us observe weather conditions in real time and make sure that all of the equipment is operating correctly during a storm. Inside these canisters are the flares with the seeding agents. The canisters are used as spark arresters, so they prevent sparks from reaching the ground. So if we pull off the spark arrestor, you can see the flare inside. The ignition of the flares are controlled from the control module that's behind us. So the white triangle there is a cell service modem, and then the solar panel keeps us powered. Inside we have a battery and then a control board. So the control board interacts with the software. We're linked or synced with the software in Utah currently, and that allows us to fire or ignite any of the flares from that remote location.
Because of the lack of clouds and proper wind conditions, today is not a good day for cloud seeding at all. But Garrett and his team are going to light a flare for us anyway, so we can show you how it works. There's just one small problem. The battery in the control module died shortly before we arrived, but it's nothing a little jump start can't fix. After a little juice from Garrett's truck, it's time to set off the flare.
The primary seeding agent in this is silver iodide. Silver iodide is a simple compound. It's polar in nature like water, so there's chemical properties that help attract water molecules to silver iodide. It's also structured molecularly similar to ice. So it helps generate or helps spawn the generation of ice buildup, and then that becomes a hailstone or a snowflake that falls here primarily as rain. So one flare like this has billions and billions of potential sites for that water to congregate around. We'll launch them in sequences. We watch the radar to see when bands of the highest concentration of liquid water are passing above us in the clouds, and we try to target those high concentration pockets in the storm systems. We'll launch between 3 and 20 flares for a typical storm. Once the flare is lit, it takes a little bit of time to carry up into the clouds, and once it's up at the proper elevation, it'll take about 20 minutes to instigate the rain or the snow process. So overall, you're probably looking at about 40 to 45 minutes before you're seeing the maximum result. And that's why we're stationed miles away from our target area. So we have very specific targets that drain directly into major water basins, and we time these events to correlate with rain above those intended targets. One of the biggest questions or most common questions that we receive relates to the safety of silver iodide. Silver is biologically inert, so it will not interact in a negative fashion with plant or animal life. Iodine is actually a critical building block of a number of hormones in animals, so it is safe as well. In fact, if you look at table salt or baby formula, you'll see iodine in its molecular form as an additive in those commonly consumed substances.
But what about other potential adverse effects? Could cloud seeding affect communities outside the targeted areas?
Sometimes there is a concern about robbing Peter to pay Paul. So are we benefiting California at the expense of Nevada? And the truth is that storm systems, when they move over off the coastline, only about 10% of that moisture is going to fall in the form of precip. And we're looking at increasing that to about 11% because we have about a 10% increase in the natural storm's productivity. So going from 10% to 11% in California has an insignificant impact on the amount of precip that will still be available in Nevada or Utah.
Built into the program are kind of checks to make sure that we don't come across anything negative. When there are high intensity storms, we won't seed. If the reservoirs are full, we won't seed. If the rivers are flowing a lot, maybe near flood capacity, we won't seed.
We hope that the conditions that exist right now will turn around and that we will not face the severity of droughts that we're facing, particularly this year. But a number of scientific articles are suggesting otherwise. And as we look into the future, we need to again consider conservation first. So the ability for us is to conserve how we use water and the ways that we store the water. And then layer on that efforts like weather modification and cloud seeding to help increase the rainfall that we do receive. It's very important that we take advantage of every opportunity we have to generate water in a sustainable way.
Anybody who's interested in learning more about cloud seeding, I've got links to scientific studies and official reports down in the description. Thank you so much for watching. Hope you enjoyed this video. Please like and subscribe for more. If you want to see more What the Future episodes, check out this playlist right here. Hope this video seeded your imagination. Conserve water. See you next time.